For our next intro topic, we're going to look at some word problems. Now, I know it's usually not your favorite concept, but it's part of algebra. Ultimately, we learn to do algebra so that we can apply it to some applications. Now, these word problems, they in no way encompass every type of word problem that you might see, but we're trying to get you to think about expressions. Expressions, of course, use letters and variables like what we have here, s and 4s, and then how expressions can create equations like s plus 4s equals 70. So that's our goal. Think about some expressions. How does that relate to an equation, and what does that mean? So we're going to try to set up some problems, and then we'll try to solve them. So in class, we will give you an opportunity to look at this little activator problem. So I want you to do that. As I already mentioned, s is a smaller angle, 4s is a larger angle, and then we see s plus 4s equals 70. So which one of these basically sentences or little statements best match this expression and equation? What do you think about statement 1? It says that the sum of two angles is 70. Well, s is one angle, and you have to understand that 4s is another angle. So it looks like we're adding, that's the sum of these two angles. That seems to match pretty good. The larger of the two angles is 4 more than the smaller. We see here 4s. Does 4s represent 4 more than the smaller? How about number 2? The product of two angles is 70. Now we see the word product. Product is going to imply multiplication. As we've already noticed, we have the sum or the addition of these angles. So I'm not liking the way that matches up. How about number 3? The sum of two angles is 70. We already have confirmed that. It says that the larger of the two angles is 4 times the smaller. Remember up in the first one, it said that it's just 4 more the smaller. So we have to understand that to be 4 times would represent a product like we have right here, this 4s. 4 more would be represented actually with a plus sign. So do you realize that the 4 times the smaller is what we're seeing with 4s? And that, of course, means that number 3, that is statement number 3, is our one of choice. Now, if you're going to solve for each of the angles, that should be pretty easy to do. We're just going to take this equation. Now, we would say that s plus 4s are like terms, and they add together to be 5s. And when you divide both sides by 5, a little basic algebra there, you're going to end up with your s. Now, what we want to realize is that s is indeed the smaller angle, 14 degrees, but the larger angle, as it shows up here, the larger angle is 4s. And so we're going to need to find the larger angle by, you might say, plugging back in. You could plug 14 back in here, or just a basic 4 times 14, and that gives you 56. Now, whenever we do a word problem, we like to label our answers. I think I labeled this with the word larger, but I should label 14 with the word smaller for that smaller angle. All right, so let's dig a little deeper into some of these word problems. Like I've said, it's not easy. What we're about to do is actually backwards from what happened up top. I'm going to try to get us to actually create the situation. In other words, create the sentences that would be modeled by these expressions. So I know you can read. It says A is Allie's age, and it says 2a minus 3 is Mel's age. And then we see this equation where some things are being added and subtracted equal 39. Now listen, if we want to turn this into a sentence or so, I'm not talking about just writing out with words what's already written here. We want to make sense of this. We want to make something that sounds real. You say, yeah, Miss Naylor, this is just kind of mathy stuff, but yeah, I think we can actually we can understand, starting with this minus 3 that we see here, that minusing 3 is like taking away. Now, if you take away from 2a, and that equals Mel's age, if you're taking away, that means Mel is younger. You realize that Mel is younger just because that's subtraction sign. Now, what's she younger than? She's younger than 2a. What's 2a instead of just saying 2a? Isn't 2 times a like being twice a? Being twice Allie. You see where we're trying to go with this? Mel is. Mel is. That would be the equal sign, of course. So Mel is 3 years younger. Now, she's 3 years younger than 2a, but we decided that 2a is twice Allie's age. So she's 3 years younger than twice Allie's age. All right. What do we got here? A plus 2a minus 3. Do you sort of see the two expressions, the two quantities that I put parentheses around? Each of those is a person. A, this first one here, that's Allie. 2a minus 3, that's Mel. So what's happening with Allie and Mel? Yes, we're adding them together, but can we say it a little bit nicer? Can we say that adding is like the sum of their ages is 39. Now, normally when you have a word problem, there's a question, and it would make sense here that what we're trying to do is we're trying to find each age. We're trying to find both ages. Now, keep in mind that that would mean that we're going to solve the equation, but we also have to do a little extra work to get both of their ages. Let's solve the equation. What do we got? Can we get some space here? A and 2a, we can and should add those together. Those are like terms. So now you have 3a minus 3. And then you're got two easy steps. Of course, you always do inverse operations. So we're going to add 3. That gives you 42. Just kind of put that in there. And then we're going to divide by 3. And that gives you a equaling 14. Now, whenever we do a word problem, we like to label what it is that we found. So I believe that's Allie's age. I just realized I wrote Al up here. So Allie's age up there. And then why don't we plug 14 back in? Now make sure you plug it back in to just the Mel equation. So we're going to plug it back in there beside the number 2. And that means that 2 times 14 minus 3, because she's 3 years younger. So 28 minus 3, 25. That's going to be Mel's age. We'll label it. You always want to label your answers in a word problem. How about example 2? Something totally different. It's not the same problem. What do we got? We're trying to find fractions. Okay, that sounds like fun. A whole object's broken into 4 pieces. They're all different sizes. Each piece is 2 times the size of the next smallest piece. It should really say 2 times the size of the previous smaller piece. We should probably change that to be the word previous. Now, here's what we want to understand. We don't know how big the first piece is. So we got to start somewhere. So we're going to start with x. X is the size of the first piece. Now, once you, I before E, once you know that x is the first piece, it says that each piece is 2 times the size of the previous. So how do I represent 2 times this piece? Well, that's pretty easy. It's just going to be 2x. Do you understand that that's the size of the next piece? How about the next piece? It's going to be 2 times 2x. 2 times 2x is 4x. And then the last piece is, one more time, it's 2 times that size. Now, what's 2 times 4x? Be careful, that's 8x. Not 6x, but 8x. Now, what am I going to do with all these x's? Well, let me show you. What you want to realize is that they represent, put together, they represent the total size of this object. So you might say that there's the size of the object is 15 x's. Again, that's like the whole size, the whole object. Now, if you're like, what's x? Well, we don't know. Okay, we don't know. X is just the size of the first piece, but it's kind of like we have 15 x's to represent the whole object. That means, are you ready? That means that the first piece, which is x, is just 1x out of the whole 15x. So the first piece only represents 1 out of 15. The next piece represents 2 x's out of the 15 x's. Okay, now these x's are going to cancel. I forgot to mention that. But that means the next piece represents 2 of the whole 15s. Are you catching on? Yeah, we're going to have 4 of the whole 15s, or 4 15s. And then the last one's going to be 8 of the whole 15. Now, here's the thing. I still don't know how big the object is, but I do know that the first piece represents 1/15 of the whole object. The next piece represents 2/15 of the whole object. 4 and 8. Kind of interesting that 15 ends up being your magic number, which is an odd number, but yet every piece is twice the size of the previous. Okay, now if you're still stuck on solving for x, you realize I can't solve for x. I didn't create an equation. This one I more interpreted just with expressions. 2 practice problems. 2 practice problems. Now, you got to be careful if you're watching these videos, either because you're absent or you just need some help. You need to try the practice problem. Don't just wait for me to go over it. If you were in class, you'd actually be trying to do practice 1. So read about Mrs. Smith. See if you can set up some expressions. See if you can set up an equation. And in practice 2, got some information about marbles. So push pause. See what you can do. Okay, now if you have started looking at practice 1, but you're a little stuck getting started, you got to think about what it is that you don't know. You got to think about which day has the least information. Is it the first day? Well, it says something about the first day, doesn't it? It says on the first day she traveled 3 times. Is it the second day? It actually is the second day, but if it's not the third day, because on the third day it talks about also something that she did. So we want to understand here that we don't know anything about the second day. And when we say the second day, we mean how far did we go on the second day. But we'll just say second day. That's good enough. So the first day. What equals the first day? It says she traveled 3 times as far as she did on the second day. 3 times the x. And in the third day, it says that she traveled 2 times. Now it says that she traveled 2 times what she did on the second day. So that's just going to be 2x. We still need an equation. Your equation can be the sum of each day. So the first day, 3x, plus second day, x, plus the third day, the third day uses a 2. X is going to be 720. That's going to bleed into my other problem over here. We'll try to squeeze that in. So it's pretty easy to solve. We just get a nice little 6x equaling 720. So x is 120. Now what does x represent? It represents the second day. So this is the kind of problem where we want to make sure that we go back and answer the question. I can Put a little 120 here. I need three 120s. That's going to be 360. And then I need two of them. That's going to be 240. But I want to go back and make sure I answer the question. Technically, these numbers here are my answer. How about the marble problem? Kind of looks a little bit like the fraction problem from up above. We've got three different sets. It says the middle set's twice the size of, or 2 times the size of the small set, and the largest is 3 times as large as the middle. Okay, when I read that, I realize that the thing I don't know, the thing I know the least about would be the smallest set. So we always want to let our variable be what we know the least about. So x is the smallest. Now, when we say x, we mean like the size of it. Okay, the size. The smallest set size, or maybe we should say size of, yeah, we could say size of the smallest set. Now, what does it say about the middle set? It's 2 times the smallest. So that's going to be your middle set. And what's it say about the largest? It says it's 3 times the middle. Now be careful, 3 times the middle is going to be 3 times 2x. 3 times 2x actually comes out to be 6x. So our largest set is represented that way. Now I don't want to set up an equation. I more want to realize that the total amount of x's is 9. When we say 9x, that would be the size or the whole size. So that means that to have the smallest set only being one of those x's out of 9 x's, or if we cancel those x's, we end up with 1/9. And then each set, the 2 of x's out of the 9 x's, that's 2/9. And then my big one is 6/9. Of course, 6/9 can be reduced, but it kind of helps you see how much each set represents. Only 1/9, really only 2/9, and then this one all the way up to 6/9. We're going to do a little bit more with word problems in our next class. You guys are going to practice some problems. For homework tonight, though, it's a little different. Kind of switch things up. Come on. There we go. It's a little, what do we call this here? Kind of I think it's called like a sum of. Basically, you're going to solve each equation. You're going to solve each equation, and the answer that you get for each equation, you're going to sum. And we're trying to find out if you can get the right answer for all 4 equations and then sum all those numbers up to get the total right answer. It's just something a little different. I actually do something kind of fun with the sum. If you get them right, I'm going to give you some bonus. But why don't you solve each equation, of course, correctly, as a little bit of practice. Remember, if you have the distributive property represented in an equation, you have to distribute, you have to multiply to each part. And typically, when it comes to the distributive property, that's something that you do first before you start doing the rest of the equation. You know, like moving things around, like putting the x's on the same side. I would most likely put the x's over here. So that gets you started. See if you a little practice with each of these equations, and then we'll follow up tomorrow.